Hey everybody, welcome to this latest algebra video, and this is going to be our nothing but factoring video. The only thing we're going to do in this video is factor quadratic trinomials so we can get really good at it. We need to get good at this because there's a whole lot of other things we're going to have to do in addition to factoring our trinomials. So let's get started with this, and we're going to use what we call the diamond method to factor. Now the diamond method works really well on the easiest types of problems. Doesn't work so well on more difficult problems, but once we get to more difficult problems, we'll have a much stronger footing if we can just, do a bunch of factoring now. So we got to have some proficiency in factoring, which is why I encourage you to use the diamond methods. So the diamond method works like this. We've got 4 diamonds, red, blue, yellow, and white. So the blue times the yellow has to equal the red diamond. And then the blue plus the yellow has to equal the white diamond. Those are the only 2 rules that we need to follow. And if we can fill in the diamond correctly, then we can also factor. So let's look at this first problem. We've got to put the numbers to start off with in the correct place. So I notice that this is a trinomial, and I'm looking for the constant term, the term that doesn't have a variable. And that's the plus 1, 18 right here. Now the constant term always goes in the red diamond. So we go with the plus 18 in the red diamond. The next term I'm going to look for is the coefficient of the linear term. And the coefficient of the linear term is plus 11. That goes in the white diamond. So now that I have the red diamond and the white diamond fill out, I can do the blue diamond and the yellow diamond. Now there's a couple of tricks I'm going to give you, and the first trick is to figure out first of all if the red diamond is a plus or a minus, and it happens to be a plus. And that's going to be our rule for factoring. We're going to add things together, and specifically what we're going to add together are the factors of 18. We're going to add the factors of positive 18 until we get a positive 11. So what are the factors of positive 18? Well, it's 1 times 18. And if I add those together, I get a 19, which of course is not what I'm looking for. The next set of factors is 2 times 9. And if I add those, I get 11. Which is what I'm looking for. I'm looking for 11. So now I just have to put 2 and 9 into the blue and yellow box. Now it doesn't matter which one you put where, as long as you put them in somewhere. So 2 and 9. Now I need to decide, is it going to be positive 2 and positive 9, negative 2 and negative 9, positive 2 and negative 9, or maybe negative 2 and positive 9. And this is a really easy problem because, they have to multiply to make positive 18 and add to make positive 11. And the only way to do that is if they're both positive. Positive multiplied by positive gives me a positive red square. Positive plus positive gives me a positive 11 in the white square. Now that I've filled in my diamond, I can factor this really easily, because x squared plus 11x plus 18, that's going to equal x plus 2. Now this plus 2 comes from the blue diamond, and then x plus 9. And the plus 9 comes from the yellow diamond. And that's it. We have successfully factored. Let's move on to our next problem, where we have u squared plus 10u plus 9. So maybe let's try this again. We're looking for the constant term, the term that does not have a variable, and that is plus 9. So we'll put a positive 9 in the red square. We're looking for the coefficient of the linear term. That's u to the first power. And the coefficient of the linear term is plus 10. So we'll put a positive 10 in the white square. I know that we need to add because the red square is positive. So let's start getting the factors of 9. There's 1 times 9, positive 1 times positive 9. And if I add those together, I get 10. Well, would you look at that? I am finished. 1 and 9. How about signs? Is it positive 1 and positive 9, or negative 1 and negative 9, or maybe one of each? Actually, it's got to be positive and positive, because positive 1 multiplied by positive 9 has got to equal to positive 9, which it does. And then positive 1 plus positive 9 has to equal whatever is in the white square, which happens to be 10. So this is looking good for us. All right, now we just have to factor. And we can write our problem, u squared plus 10u plus 9 is equal to our factors. U plus 1, remember the plus 1 comes from the blue square. I realize using a blue highlighter on a blue square is not the best idea. And then also u plus 9, and remember that 9 comes from the green, the yellow square. The plus 9 comes from the yellow square. And that's it. We have factored our second problem. Let's keep moving because I'm hoping you're feeling confident now. Let's take a look at number 3. N squared plus 3n minus 18. Okay, look for the constant term. The term that doesn't have a variable is minus 18. So we'll put a minus 18 up there. Look for the coefficient of the linear term, and it's plus 3. Let's identify this is a subtraction type. So we're going to do some subtraction. And let's see, what are the factors of 18? Well, there's 1 times 18, and if I subtract, I get a 17, and that doesn't work. I'm looking for a 3. Also, there's 2 times 9, and if I subtract that, I get a 7. That doesn't work. I'm looking for a 3. And then there's also 3 times 6, and if I subtract 3 and 6, I get a 3, which is just what I was looking for, a 3 and a 6. Okay, 3 and 6, let's put them in here in no particular order. And I know one of them's got to be positive and one of them's got to be negative. That's the other thing this subtract tells me. One of them is going to be positive and the other is going to be negative. So which one of these is going to be positive? Which one of these is going to be negative? And I think it's going to be, let's make a mistake. Let's do this one. Positive 3 and negative 6. And let's say, okay, positive 3 multiplied by negative 6, positive 3 times negative 6, yes, that's equal to negative 18. But positive 3 plus negative 6, if I add them, I get a negative 3, and that is not correct. The correct way to do this is negative 3 and positive 6, because negative 3 multiplied by positive 6, that is equal to negative 18. And also negative 3 plus positive 6, that's equal to positive 3. And that's correct because that's what's in the white box. So there we go. The red box worked, the white box worked, and we're ready to write down our answer, which is n squared plus 3n minus 18 is equivalent to n minus 3. Remember that minus 3 is from the, okay, you can't even see that. That's embarrassing. The minus 3 is from the blue box. And then we have n plus 6. And the positive 6 is from the yellow box. So that one was a little bit more intense. Let's try the next one. We've got x squared minus 3x minus 40. We'll put the numbers in the box. We've got the constant term is minus 40, so we'll put a negative 40 in the red box. The coefficient of the linear term is negative 3, so we'll put a negative 3 in the white box. In our head, we'll think this is a subtraction type. So we're going to have to subtract our factors, and we're going to look for negative 3. Okay, let's go ahead and list the factors of 40. What are the factors of 40? 1 times 40. And if I subtract 1 and 40, I get 39. And that doesn't work. Okay, let's try another one. How about 2 and 20? I shouldn't write an equal sign there. If I do 2 and 20, I subtract and I get 18. That doesn't work. How about 3? No, 3 doesn't go into 40. How about 4 times 10? And 10 minus 4, that is 6. That's not going to work. Ooh, I'm running out of factors here, aren't I? What about 5 times 8? Oh yeah, that works. 8 minus 5 is actually 3. Now if I want to get a negative 3, I'm going to have to do a negative 8 and a positive 5. So let's check. Negative 8 multiplied by positive 5, is that going to be equal to the number in the red box? Yes. And then if I do negative 8 plus positive 5, is that going to give me the number in the white box? Yes, this is in the white box. So we're good. We have the correct factors, and we can just write it out. X squared minus 3x minus 40 is equal to x minus 8. Remember that the minus 8 comes from the blue box. And x plus 5. Remember that the plus 5 is coming from the yellow box. And that's good. Let's move on because we're having so much fun factoring these. I'm having so much fun factoring these with you that I thought we'd go to the next level. And the next level here is, what if we have an equality? Okay, if we have an equality, the first thing we got to do is make sure it's equal to 0. And if it equals 0, then we're good to start. All we need to do is factor the left side of the equal sign. So let's factor this. We'll do this a lot faster. We've got plus 10 in the red box, minus 7 in the white box. Let's figure this out. It's a positive problem, so 1 times 10, if I add it, I get 11. That's no good. 2 times 5, if I add it, I get 7. That is good. So I'm going to need a 2 and a 5. And if I want to add to make a negative 7, it's got to be negative 2 and negative 5. Let's check. Negative 2 multiplied by negative 5 is in fact equal to positive 10, the red box. And then negative 2 plus negative 5 is indeed equal to negative 7 in the white box. So we are set, and we can now factor. So w squared minus 7w plus 10, that's equal to w minus 2 from the blue box, and then w minus 5 from the yellow box. And that is equal to 0 because of the equals 0 over here in the original equation. Now, we're going to use what's called the zero product theorem. And in the zero product theorem, if we've got two things being multiplied and it equals 0, well, then one of those two things has to equal 0. So either w minus 2 equals 0, or w minus 5 is equal to 0. Let's solve these two. W minus 2 equals 0. And we're going to add 2 to both sides. Remember, I like to add 2 like in this way, because that makes more sense to me. So w is equal to 2. And then we're going to solve the other equation. W minus 5 equals 0. And then we're going to add 5 to both sides. That's just the way it makes more sense to me. And so w is equal to 5. So our solution here is either w equals 2 or w equals 5. Second degree equation, 2 solutions. That's not a coincidence. Okay, so let's move on to another one of these types of problems. Okay. So danger, this is not equal to 0. Doesn't equal 0. So we've got to make this equal 0 using our solving techniques. Let's do some solving techniques. T squared minus 7t equals 8, and we're going to subtract 8 from both sides. And that gives me t squared minus 7t minus 8 equals 0. So now this equals 0, and I'm set to factor. Okay. Let's put the constant term in the red box. The constant term is negative 8. And let's put the coefficient of the linear term in the white box. The coefficient of the linear term is negative 7. So it's a subtract problem. I know I misspelled that. Subtract problem. What are the factors of 8? Well, 1 times 8. And if I subtract that, I get, oh, look, I get 7, which is what I'm looking for. All right, so it's a 1 and a 7. One of those needs to be positive. One of those needs to be negative, and I know it's not a 7, it's an 8. So that should be a negative 8 and a positive 1, which means t squared minus 7t minus 8 is going to be equal to t plus 1 from the blue square and t minus 8 from the yellow square. And we know that that's equal to 0. So t plus 1 equals 0, or t minus 8 equals 0. That's the zero product theorem. Let's solve the first one. T plus 8 equals, why did I say 8? T plus 1 equals 0. And then we're going to subtract 1 from both sides, giving me that t is equal to negative 1. Over for this one, we're going to do t minus 8. And then we're going to add 8 to both sides. Let's add 8. Let's do that in red to be consistent. Add 8 to both sides. And that gets me t equals 8. So my solution, t is either equal to negative 1 or t is equal to 8. Perfect. Lots of good stuff going on here. Let's move on to our almost the last problem here. We've got r squared minus 3r equals negative 2. This is not equal to 0. So we're going to do some solving. We've got r squared minus 3r equals -2, and we're going to add 2 to both sides to get that 0 pair on the right. And that gives me r squared minus 3r plus 2 equals 0. Let's look for the constant term. Sorry, we should say this equals 0 now. We're going to put the constant term in the red box. That's +2. We're going to put the coefficient of the linear term in the white box. That's a -3. And we notice that this is an addition type problem. So we need to add our factors. How do I multiply to make 2? That's just 1 times 2. When I add that, I get a 3. Good. So one of these is going to be a 1. One of these is going to be 2. And they both need to be negative in order to add to make -3. Just to do our check, -1 multiplied by -2, that's equal to +2 in the red box. And the -1 plus -2, that's equal to -3 in the white box. So we did well here. Now we just have to do the factoring. Let's put a little bit of a line here. Factor r squared minus 3r plus 2 is the same thing as r minus 1 from the blue box and r minus 2 from the yellow box, and that's equal to 0. Using the zero product theorem, r minus 1 equals 0, or r minus 2 equals 0. Let's solve both of these, and we're going to save some time. We've already seen me solve these pretty slow. So this is r equals 1, or r equals 2. And that's our solution for number 7. Picking up speed here. Let's take a look at number 8, our very last one for this video. We've got k equals 5k minus 6, and this is not equal to 0. We're going to have to do some solving here. So we're going to have to do a lot of solving here. So we're going to do k squared, and that's equal to 5k minus 6, and then we're going to subtract 5k from both sides. And then we're going to add 6 to both sides. And what does that get us? That gets us k squared minus 5k plus 6 is equal to 0. All right. Linear term is a plus 6. That goes up in the red box. The coefficient of the... Did I say that wrong? The constant term goes in the red box. That's a plus 6. The coefficient of the linear term is -5. That goes in the white box. So this is an addition type problem. Addition. So we're going to add the factors of 6. Let's do 1 times 6. If I add 1 plus 6, that gives me 7. No good. 2 times 3. And if I add 2 times 3, I get 5, which is what I'm looking for. I'm looking for a 5. And in order to make that a -5, it's got to be a -2 and a -3. That's how quickly that goes. So we have our factors. So k squared minus 5k plus 6, that is equal to k minus 2 from the blue box and k minus 3 from the yellow box, and that's equal to 0. Using the zero product theorem, k minus 2 is equal to 0, or k minus 3 is equal to 0. Solving this first one, you get k is equal to 2. Solving the second one, you get k equals 3, and we are finished. So good work, everybody. That was a lot of factoring that we just did, and hopefully that made factoring a lot easier for you, and we'll see you on our next video. Bye-bye.